Good morning and afternoon, whichever time you're watching this. This is the video that I put together for today's lesson, but I want to start with last night's homework. So let's go ahead and look at number 15. Again, remember with these 15 and 16, you were just going to find the partial sum. If you notice with this particular problem, it's changing by subtracting 7 every time. So since they need the sum all the way through the 12th term, and they only gave me 5, I went ahead and subtracted 7 until I had 12 total terms. And then, of course, to find the answer, I simply added all of those numbers together. Okay, if you notice, there's about as many negatives as there are positives, and that's why the value ended up being a -6, right? So pretty easy there. Hopefully you got that right. Number 16, again, the only thing that was difficult possibly about this problem was recognizing the pattern. 1, 8, 27, 64, 125. Those are all perfect cubes. So that's exactly what I needed to do to find the last couple. This is 6 cubed. This is 7 cubed. So my S sub 7 is 784. Okay? So if you did get those, make sure you mark them in your homework. And we're going to look at the back. Again, some of your classes, I gave you all of them, but I asked you to expand the even ones. Some of you only had to do it just by typing it in the calculator. For example, number 17 is 21. Number 18, again, remember what it means to expand it is go ahead and show me all of the values that you get when you do terms 1 through term 9. So when I plug all those in, this is what I get. Of course, summation means we're going to take those values, we're going to add them all equal to each other and get 180. Again, please check in your calculator to make sure that you did this correctly. All right. Number 19, the answer was 5. Number 20, here you have it. I want to show you guys something real quickly that could be very useful to you. When you think about doing terms 1 through 8 into this equation, that could be kind of tricky to come up with all those. 1, 2, 3, 4, 5, 6, 7, 8 terms. I want to remind you, these are explicit formulas. So if you want to come up with those really quickly and really easily, I recommend you open up your graphing calculator. And again, since these are explicit formulas, what I would love for you to try to do is, to save yourself some time, go to y equals. Then you can type that equation in. Type that explicit formula in. So this is 3, and it was y, of course, but we're going to use x squared minus 2x. And then instead of looking at the graph, look at the table and check this out. There's your first term, see, 1. Second term, 8. Third term, 21. Fourth term. So you actually don't even have to plug those in. You could just go to your calculator, remembering that explicit formulas, I could just graph them and look at the table, and there's your first term is always going to be where your x value is 1. So you can look at this at whatever you need. Like, for example, on number 21, you don't need until the third term. So again, you can look at this table and you can find them all real quickly. So that might save you some time there. Might be something to look into doing. But anyways, to expand that, if you typed all those in individually, that might have been tricky. But if you go to your calculator and use your table, it's going to be a lot faster. Here's number 21. Just type it in, 194. 22. Again, expand that. And feel free, go check it in your graphing calculator. Go to y equals, type in this right here, your explicit formula, and sure enough, go look at your terms from your second term to your 7th term, and boom, there they are. And of course, type in your calculator, add them all together. Number 23, I asked you guys to do because it did have that little trick to it. So the answer for that one was 2298. And then 24, you were supposed to expand it as well. Again, I went to my calculator, got these values from term 3 all the way to term 11, and then of course plugged it in and checked it, and sure enough, 9/4 is the answer. So pretty simple assignment yesterday. I think you guys probably did just fine. Anyways, if you have any questions over this or what we do today, feel free to mark it. That way when I come back, when I return to school on Monday, you can ask me specifically about the things that you're struggling with. All right, well, Mr. Bingham was supposed to hand out, or is going to hand out now, the notes for today. Today we are dealing with arithmetic sequences. So I'm going to assume that he's given those to you, and we're just going to jump right in That way I can hopefully get you guys done in time for you to actually work on your homework. So here's the first type of sequence that we're going to be able to actually write the equation for. Okay, arithmetic sequences are sequences, so it's a sequence in which the difference between consecutive terms is constant. So what that means is a particular sequence is making the same change from one term to the next. Okay? So if it's making the same term from one to the next, if it's adding the same number or subtracting the same number, then it will definitely be considered an arithmetic sequence. So one of the things that's extremely important for us to be able to find when we're dealing with an arithmetic sequence is the common difference. The common difference describes how that sequence is changing. So how we're going to find that common difference every time is we're going to name it D. Okay, so our common difference, lowercase d, will equal, and you're always going to follow this order. Second term, so a sub 2, minus first term, a sub 1. So you're going to do second term minus first term. Okay? So let's look at these examples and let's answer what it asks. It says, first, determine whether the sequence is arithmetic. If it is, then identify the common difference and give the next three terms. Okay? So what I'm going to do is, without even looking at this whole thing, I'm just going to say, okay, hey, if it's going to have a common difference, or if it's going to be arithmetic, it has to have a common difference. And how do I find that common difference? I take the second term. Which one's the second term here? 8. And I subtract the first term, 5. Well, 8 minus 5 is 3. So here's the question. Is this thing changing by increasing by 3 every time? Does 8 plus 3 equal 11? Does 11 plus 3 equal 14? Does 14 plus 3 equal 17? Absolutely it does. Therefore, without a doubt, this thing is arithmetic. Okay? So the question asks, well, what's the next three terms? Well, let's just keep adding 3. What's 17 plus 3? 20, 23, 26. That's it. That's all there is to determining whether a sequence is arithmetic. You take the second term, subtract the first term, and then you just double check to see if that's what continues to happen. So let's look at the very next example. Let's take the second term, 2, and let's subtract the first term, 1. Well, what is 2 minus 1? Well, definitely that's 1. So let's check to see if that's what's happening. Does 2 plus 1 equal 3? Yes. Does 3 plus 1 equal 5? No, it does not. So see, I don't care that 2 plus 1 gave me 3. It's got to happen every time. It has to be constant. It's got to change the same way every time. So this one is not arithmetic. Now remember, if it's not arithmetic, then does it have a common difference? No, it doesn't have a common difference because it's not arithmetic. It can only have a common difference if it's arithmetic. So this one is not. Okay, look at number 5. This one might be a little more tricky because we're having to deal with negatives. But please remember, you always take your second term, that's negative 10, and you subtract your first term, which is negative 20. Now I know that that's minus a negative. What happens with minus a negative? Well, it turns to adding, so negative 10 plus 20 is a positive 10. So we want to double check to see if this thing is adding 10 every time. Well, negative 10 plus 10 is 0, not negative 5. So this one also is not arithmetic. Well, let's do one more. Let's look at number 2. And again, common difference can be found by taking the second term, 16 in this case, and subtracting the first term, which in this case is 23. Listen, don't get in the habit or in the thought process of thinking you always have to take the big one and subtract the small one. That's not the formula. The formula is you take the second term and you subtract the first term. That's why we do 16 minus 23. Now, the answer to that is minus 7. So this one, does it have a common difference of negative 7? Is it subtracting 7 every time? Well, 16 minus 7 is 9. 9 minus 7 is 2. 2 minus 7 is negative 5. So sure enough, this one is arithmetic. So let's just keep on subtracting 7, and we'll find the next 3 terms like the instructions say. So negative 5 minus 7 is negative 12. Negative 12 minus 7 is negative 19. And negative 19 minus 7 is negative 26. So there it is. Determining whether a sequence is arithmetic, and if it is, we identify that common difference and give the next 3 terms. All right? Very good. Now, let's get back to what we were talking about the other day. The other day I told you, listen, some of these equations that we're having to come up with when it comes to these recursive and explicit formulas, they were pretty challenging. Some of them we had to really kind of think through what's going on. And I told you, don't sweat it. As we move further on and we start dealing with specific types of sequences, like arithmetic, there's going to be a formula that you follow where you can find your equation easily and consistently. And here is that formula. A sub n, so it's saying for any term that's in this particular sequence, A sub n, you can find it by taking A sub 1. That's my first term, right? Whoops, it went crazy on me. So my first term. And then I add n minus 1 times d, where d is my common difference. Okay? So that is how we can actually write and come up with a specific sequences formula. Okay? And this only works for what? Arithmetic. So if we know that something is arithmetic and we see what that sequence is doing, we can find that common difference, then without a doubt, we can write the equation for it. So let me show you what this looks like. Okay, we're going to do a couple of these. So let's look at number 7. And you see how it says write a rule for each sequence? So we actually don't even have to check to see if it's a sequence. It's telling us it's a sequence. So let's write the rule for it. And then it says find the indicated term. So first of all, let's start with writing the rule. Well, I can't write the rule without knowing my common difference. So remember how I find that? Second term, guys, what's my second term? Negative 1 minus my first term, negative 5. Well, minus and negative turns to plus 5. So negative 1 plus 5 is positive 4. Now listen, that's not finding an equation. That's just finding my common difference. We're going to use the equation that's up there to find A sub n. Ready? Here we go. A sub 1. Now remember, you're not having to come up with your first term. It was given to you at the very beginning. Your first term is negative 5. Plus, you're going to leave n minus 1 in here because it's a part of your formula, and you're going to multiply that by the common difference, which is 4. Now you guys know as well as I do, multiplication comes first, so we're going to distribute here. So just leave this negative 5 alone for the time being, and let's distribute. So remember, we have this plus here. What is 4 times n? 4n. And what's 4 times negative 1? Negative 4. Now, as you guys notice, you have 2 constants here, negative 5 and minus 4. So here's how I'm going to write my equation. A sub n equals, I always like to start with my variable term. Which one's my variable term? 4n, positive 4n. And then what does negative 5 minus 4 equal? Negative 9. So my equation that represents this arithmetic sequence is A sub n equals 4n minus 9. So once we have that, the next question is actually really simple. I'm just going to do it kind of over here to the side. I've written kind of big, so ran out of space a little bit. But see how they asked me to find A sub 24? Well, to find A sub 24, remember how we know how to do this? To find the 24th term, Now that I have the explicit formula, right, 4n minus 9, can't I just plug 24 in? So 4 times 24 minus 9. So if you type that into your calculator, the answer is 87. And that's it. That's how you do this. This is how you write the explicit formula for an arithmetic sequence. Pretty simple, right? Let's look over here at number 8. I'm going to leave that over there in case you didn't quite have it all typed up. Remember, just like the instructions on the last one, they're telling me, hey, this is a sequence. So let's find the common difference. Second term, 11, minus first term, 20. 11 minus 20 is negative 9. So there's my common difference. So here we are ready to write our equation. A sub n equals a sub 1, that's 20, plus n minus 1 times d, which is negative 9. So I'm going to leave 20 alone for the time being, and I'm going to distribute that negative 9. Well, negative 9 times n is negative 9n, and negative 9 times negative 1 is positive 9. So just like the last one, I like to put my variable term first. So negative 9n, and then 20 plus 9 is positive 29. So there it is. That is my explicit formula for this arithmetic sequence. So this one particularly asked me to find a sub 15. So I'm literally going to go negative 9 times 15 plus 29. So negative 9 times 15 plus 29 is negative 106. And there you have it. We wrote an explicit formula, and we found a particular term in that sequence. All right, so if you're confused by that, that's going to be tough moving forward, but I think you guys can understand that. It's pretty straightforward. So I'd like to go ahead and skip 9 and 10, and we'll move to the back. I'm going to show you real quickly 11 and 12. I'm going to work out just one of them, but I am going to kind of talk you through the other. What do you do if they don't give you an entire sequence, but they want you to write a rule for it? So like if you look at number 11, we don't have the first and second term. How do I find the common difference if I don't have the first and second term? Well, here's how. We're going to take the top and do the difference of the term values. And then on the bottom, we're going to do the difference of the term numbers. So even if I don't have the first and second term, I do have the first and third term. So what is the third term? Because we're still going to go in that same order. We're going to do the big one minus the small one. Okay, we're going to do the big minus small. So the a sub 3 term value is negative 7. So we're going to subtract, right, difference of term values. We're going to subtract the a sub 1 term value, 3. But then below it, we're going to subtract our term numbers. Okay, a sub 3 is term number 3. Minus a sub 1 is term number 1. So we're always doing the larger term first, and then we're subtracting the smaller term. Not necessarily based on the numbers, but based on the order. Okay, so that's why we did a sub 3 minus a sub 1 over 3 minus 1. Now, when I do that, negative 7 minus 3 is negative 10, and 3 minus 1 is 2. So my common difference for this one is negative 5. Now, once I do that, and I have my common difference, and I have my a sub 1 that was given to me at the very beginning, I can write my formula, right? I simply go, all right, a sub n equals a sub 1 plus n minus 1 times d, which in this case is negative 5. I'm going to leave the 3 plus alone for the time being. I'm going to distribute the negative 5. Negative 5 times n, negative 5n, and negative 5 times negative 1 is positive 5. Once again, I'm going to put my variable term first. That's negative 5n. And then positive 3 plus 5 is positive 8. So there it is. That is my explicit formula for this particular given sequence. Okay, how easy was that, right? So the last step it asked me to do then is it wants me to find a sub 12. So I'm going to go negative 5 times 12 plus 8. So negative 5 times 12 plus 8 is negative 52. So there it is. That's how you do it. Now, real quickly, I just want to do number 12 with you. Remember, it's the same thing. I just need to find my common difference. So I take my biggest term value. Guys, what's my biggest term value? Well, that's a sub 24's terms value, 6. And I subtract my smaller terms value, negative 17. And I put that over my biggest term, 24, minus my smallest term, 1. So 6 minus negative 17 is 6 plus 17, which is 23. And 24 minus 1 is 23. So my common difference here is 1. So instead of doing this whole problem, I'm just going to leave it to you, because if you have your common difference and you have a sub 1, you can just repeat what you did on the left. But we're going to move on. You're going to see that problem in a homework problem or two. Now, with this arithmetic series, there's actually another formula that you could learn that would allow you to do this. And I don't like it. I don't teach it. And I don't teach it because we've already done two things that will now allow us to do this without actually having to learn another formula. So I'm not going to teach it that way. I want to teach it this way. You see, with this whole concept of arithmetic series, that's the same thing that we talked about yesterday. Remember, how do we find the sum, for example, through the 10th term? Well, instead of me coming up with another formula that would allow me to do S sub 10 with an arithmetic sequence, what I want to do instead is I want to do summation for all the terms from where to where, guys, to do this particular problem. From the first term to the 10th term, right? Isn't that how it works? And I'm going to do that for the explicit formula that goes with this particular sequence. Now, I don't see that formula. Do you? No. But instead of learning another formula, can't we just use what we just learned? How do we find that explicit formula that represents that arithmetic sequence? The same way we just did a second ago. Remember, we want to find our common difference. Remember how you do that? Second term. Guys, even though it's written as a series, what's the second term? 4 minus your first term, which is 2. So you have your first two terms here. 4 minus 2 gives you a common difference of 2. Well, don't we know now our common difference and also our first term, which is 2? So I'm going to simply write the explicit formula that represents this. A sub n equals a sub 1 plus n minus 1 times your common difference, which we just said was 2. I'm going to distribute that 2, so leave 2 plus alone here. 2 times n is 2n. 2 times negative 2 is negative 2. 2 times negative 1 is negative 2. Now, I know that you recognize this. This 2 minus 2 will cancel, but we always start with our variable term, which is 2n, and then those 2's cancel. So there is the explicit formula that goes with this particular sequence. So sure enough, all I'm going to do is go insert it right here and type it into my calculator. Right? Obviously, I replaced the n with an x, so I could type it in my calculator correctly. But I'm going to go to my calculator at this point, and I'm going to do alpha, window, number 2. I'm going to define x from the first term all the way to the 10th term for the equation that we just came up with, 2x. And when I push enter, there's my final answer, 110. Is the sum of this arithmetic series through the 10th term. You see, there's no reason to learn a new formula when I've already got it. Okay? Watch how easy we can do this. What are we trying to find? We're trying to find the sum of this series from where? The first term to what? The 8th term. Look, S sub 8. We just need to know a sequence, our formula. So we start off with our common difference. Second term, negative 19, minus first term, negative 6. Well, minus and negative turns to plus. Negative 19 plus 6 equals negative 13. There's my common difference. So here we go. We're ready to write our formula. A sub n equals a sub 1, negative 6, plus n minus 1 times d, which is negative 13. Okay, let me zoom in. I'm afraid y'all are not going to see this. Okay, so we're going to distribute the negative 13, leave the negative 6 plus alone. What is negative 13 times n? Negative 13n. And what's negative 13 times negative 1? Positive 13. Again, last thing, I always put my variable part first, so negative 13n, and negative 6 plus 13 is a positive 7. There's my explicit formula that represents this sequence. So what do I do with that explicit formula? I insert it directly into my summation. So I go to my calculator and I type in alpha, window, number 2. We're going to define our variable all the way from the first to the 8th term, s sub 8, for this sequence, which we found the equation to be negative 13x plus 7, and that equals negative 412. And voila, we're done. Okay, let me go back. There it is, negative 412 is our answer, and that's how you do it. So, your homework, and hopefully you have a little bit of time to work on it, is from the worksheet that either he's handed out or it's headed your way now. It's 2 through 20 even. That's 10 problems, maybe 11. Let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, 20 or 10 problems. So, I hope you have an awesome weekend, and I'll see you on Monday.